All right, last video for the digestive system. Woo! So we're going to go ahead and get into the accessory organs. The organs that don't necessarily deal with the food directly, but they have a very good impact on basically your ability to absorb the nutrients from that food. So we're going to talk about those three: the liver, the pancreas, and the gallbladder. So by the time we get through this, you should be able to talk about their roles. You should be able to talk about the main features of the liver and histology of that. We'll talk about the composition of bile, and we'll talk about a lot of the enzymes and buffers that are coming from the pancreas to help with digestion as well. So the important thing to note with the accessory organs is that they are not part of the GI tract. They're helpful for the digestive process, but they are not actually dealing with food directly. And there's only three that we're going to talk about: the liver, the pancreas, and the gallbladder. They're mainly helping the small intestine when it comes to chemical digestion or the chemical breakdown of food. And so here we see where they're located. We see the liver, which is like the largest organ we're going to have in that cavity, the gallbladder, which is the little green guy attached to them, the pancreas, which is the fish-shaped organ, and these are going to all be kind of surrounded by like the stomach, the intestine, and the spleen. So let's start with the liver. On the front, right, we're going to see two primary lobes, the right, which is much bigger than the left, and then on the back we see the caudate and the quadrate. We have 5 different ligaments. We have the falciform ligament, the coronary ligament, the lateral ligaments, and the ligamentum teres hepatis. The first and the last one here are actually going to be the remnants of your umbilical vein. So basically part of your umbilical cord, right, the leftovers. And this is going to help separate the right from the left. If we look at the histology, we have what we call hepatic lobules. They're this nice little hexagonal shape. There's a central vein that runs in the middle of this lobule. This is going to take the deoxygenated blood away from the liver. And then we have this like triad at the corners with 3 structures: a bile duct, which is going to carry the bile that's made by the hepatocytes, a branch of the hepatic vein, which is going to carry the deoxygenated but nutrient-rich blood from the digestive tract, and then the hepatic artery, which is going to carry oxygenated blood to the liver. In terms of the direction of blood flow, right, so we're going to have blood first, then bile, because they will not mix. That would not be good. But the blood flow is going to go from the portal vein and the hepatic artery over the hepatocytes to the central vein. With the bile flow, we're going to go from liver cells to the bile canaliculi to a bile duct, right? And so blood and bile are going opposite direction. Blood is coming from the digestive system to the liver. Bile is coming from the liver to the digestive system, right? Is kind of how we can think about it. And so bile, we're making a lot of this, first of all. We're making about 1 liter a day made by the hepatocytes, which hepatocyte is just liver cell, right? Cyte, we think cell. Hepatic, we think liver. So if you think HEPA filter, why do we call it HEPA filters? It's named after the liver, basically, right? It's related to that. It filters. So bile is going to be a mix of water, bile salts, and bile pigments, including bilirubin, which is going to help give it its color, phospholipids, electrolytes, cholesterol, and triglycerides. And the whole point, like, I'm not going to expect you to memorize the composition of bile, but at least knowing the basics of it and knowing that it's to emulsify lipids. And if you don't know what emulsify or emulsification is, it basically means taking a large like blob of lipids and breaking it into smaller lipid droplets. Because the emulsification process happens too because bile is going to have hydrophobic and hydrophilic components to it. So the hydrophobic components are going to attach to the lipids, while the hydrophilic parts are going to face outside. But it's to break a big globule of lipids into much, much smaller little droplets that are easily absorbed. So if we look at the microscopic anatomy of the liver, right, again, we have this nice little hexagonal shape. We have the central vein in the middle of that hexagon. We have the sinusoids in purple that are branching out. And then we see the portal venules, portal arterioles, and the bile ducts running together like at the corners. And then running from those bile ducts, we see the little ducts running out and the canaliculi coming from that. We go to the pancreas. With the pancreas, I'm going to focus just on a few things here. It is retroperitoneum, meaning like it's outside and behind the peritoneum, but I'm not so worried about that, to be honest. What I'm more worried about here is the fact that the pancreas is both endocrine and exocrine in terms of function. Remember the difference. Endocrine makes hormones that go into a bloodstream. Exocrine makes something that goes through a duct, right? That's the definition of endo versus exocrine. And so the pancreas does both. We've already talked about the endocrine side of the pancreas. We talked about that in the endocrine system when we talked about insulin and glucagon. But now we're going to talk about the exocrine side where we're making digestive enzymes. We do have this, they say a fish shape. I still don't see it. If you see it, that's cool. But basically the head is going to be next to the duodenum. The body is the main section, and then the tail is going to be where it thins out towards the end. And then there's a pancreatic duct that runs along the middle, almost like a little spine, right? Like a little spinal cord that runs through it. It's not a spinal cord, it's a duct, but it kind of runs right down the middle there. If we look at the histology of the pancreas, right, we already looked at the pancreatic islets, sometimes called the islets of Langerhans. Same thing. This is where we would see those like alpha and beta cells making glucagon, making insulin. That's cool. We're not worried about that now. We care about the acinar cells, which are going to make pancreatic juice that are going to secrete through the pancreatic duct into that small intestine. That's what we care about now. And we make a ton of this pancreatic juice every day. We're looking at over 1 liter of it every single day. So what is this pancreatic juice? What's in it? It has salts. We have sodium bicarbonate. We have digestive enzymes. And the whole point here is to help us chemically break down the carbs, proteins, and fats in the food we eat, as well as with the sodium bicarbonate to neutralize the stomach acid as the stomach empties into the small intestine. All right, so we want to raise that pH from a really low acidic pH to a more neutral pH. We are going to come from the pancreas to the duodenum of the small intestines through the hepatopancreatic ampulla, where it's just a little part where it's going to connect us, not just with the pancreas and the duodenum, but it's also going to connect the liver and the gallbladder as well. And this whole process is controlled by hormones as well as the parasympathetic nervous system. So the parasympathetic nervous system will ramp this up, right? Part of the rest and digest, right? Part of the autonomic nervous system. And so this is what we're looking at again. So here is in yellow here, this is the pancreas. So again, they say it's fish shaped. I don't see it. Maybe a fish stick, but that's just me. But we see the head here kind of rounded out, the body right here, and then the tail is where it kind of rounds at the very end. And then running right along in the middle there, we have the pancreatic duct. It's going to join up with the common bile duct so that we can enter into that duodenum. If we look deep inside of the pancreas on a microscopic level, here's those pancreatic islets that we talked about in the endocrine system. Those are the ones making the hormones, the insulin, the glucagon. Cool, but we don't care right now. We care about these acinar cells, which are making the digestive enzymes so that we can send them through that pancreatic duct to carry off towards the duodenum. And then we get to the gallbladder. The gallbladder is that little green guy, this little muscular sac. It does have a fundus, which is like a rounded out part, the body and the neck. This is going to store and concentrate that bile produced by the liver, and then it's going to control the release of that bile into the duodenum as well. We have a mucosa that is just simple columnar epithelium with rugae. There is no submucosa. And then smooth muscle is used to kind of push the bile out of the gallbladder and into its duct. The visceral peritoneum is going to hold it under the liver, so it's going to be right up close right, just kind of almost married to the liver. You can live without a gallbladder. It's not that uncommon for people to get it removed, especially if someone has maybe like repeated infections or gallstones. For various reasons, people may get it removed, but you may know someone who, or maybe you have had your gallbladder removed. So it is an organ that is helpful to have, but not required to survive. In terms of how bile flows, we're going to start with the hepatocytes where it's made in the liver. We're going to travel to the bile duct in that portal triad in the liver to either the right or left hepatic bile duct, to the common hepatic duct, and then to the cystic duct, which is basically to take us to the gallbladder. So cystic duct takes us to the gallbladder so that we can be stored, or we go to the common bile duct, right, if we're going down towards the duodenum. We'll join up with the duodenum through the hepatic pancreatic ampulla, which again is just joining the bile duct and the pancreatic duct together so we can just dump everything that we need into the duodenum at one point. And so here is our gallbladder, and again, you'll always see it, like almost always see it, like married to the liver, right? It's held really close to the liver. But here we see the gallbladder, we see the fundus, which is the rounded out part here, the body, which is the main component in the middle, and then the neck where it connects. We have the cystic duct here, which is where this will carry bile towards the gallbladder for storage. We also will have the right and left hepatic ducts coming down to the common hepatic duct, and then the common bile duct is going to be where the gallbladder and the liver have joined forces.